Yeah, so Juraci, thank you very much for joining me today in this conversation. Um, like last week we had a chat and it was this very interesting, and I thought like maybe let's record that so we can let a few more people into this. And I recall actually in all the great topics that we talked about, but I do recall we were talking about telemetry, telemetry hygiene, telemetry kind of instrumentation on kind of like how to get it out of a process. Um, OpenTelemetry, the goods, the bads, the ugly, OpenTelemetry UIs, and so on. What did I miss? What other topics do we have?
Culture of instrumentation. So how some companies, so a company having a mature culture of observability makes it easier or easy
Yeah,
to keep going good, whereas establishing that culture initially is very hard.
yeah, that completely makes sense. But where is your top of mind today? What's going on, and what are some new topics that we could also kind of strive or think about?
So top of mind for me right now this week is instrumentation, and more specifically, how can we use LLMs and specialized knowledge to judge pull requests when it comes to instrumentation. So if I'm adding instrumentation to a code via a pull request, how can I use an LLM or an agent to use the word of the ear? How can I use an agent to judge that line of code that I've added? Is my span name good or is it bad? So this is top of the mind this week because this is what we are launching in a couple of days. So on Wednesday, we're going to launch our research preview for Rose. All of the OllyGarden internal products or projects have names in this botanical theme. So Rose is our agent, so works as a flower name and as a person, so fitting for an agent. And Rose is our initial take on one of the things that we actually I think kind of touched last week. So on one hand you have auto instrumentation with the BPF, which is very noisy. It's easy. I mean, it's the easy button, right? So you can go there, click the easy button, it gets installed across all of your nodes in Kubernetes. Suddenly you have your Christmas tree
Yep,
is
yep,
lightning with all of the different lights. But then a lot of those lights are low quality and it's a lot of lights, so you get
yeah,
blinded. And on the other hand, so the option to that is I train my engineers on what is good OpenTelemetry instrumentation, not necessarily Prometheus. Like what is good for Prometheus is not necessarily applying for OpenTelemetry. So what is good OpenTelemetry instrumentation is hard to spread within our organization. And we are trying to bridge this gap by bringing a tool that helps in the instrumentation, but with the knowledge about what is good about OpenTelemetry instrumentation. So it has access to the source code. So I have very targeted instrumentation, like spare phishing instrumentation. I don't do that at wholesale at the kernel level by watching all of the syscalls that are happening. I have access to the source code, so I know that a post to the payments endpoint is way more important than a get to the payments endpoint, and so I can have better instrumentation there, or more comprehensive instrumentation there, and I can even see that the health check extension. I don't endpoint. I don't need anything for that. I don't need to restore that if it is a 200. Like I don't care about health checks, especially if they are returning 200. I do care if they are returning 500 or so. That's where we the opportunity that we see is there in providing a tool that can look at the code and do instrumentation. At the very beginning, it's gonna judge PRs for instrumentation. But eventually, what we really want to see is that tool plugging into a repository and then opening an issue saying, those are all of the problems that I saw here, And by the way, here are some PRs fixing those issues. So this is the longer term vision. Yeah. So this is what is top of my mind right now. Sorry if I went too deep into that.
No, it's perfect. And I do actually have 3 tangents. And the first one is just maybe let's talk a little bit more about OllyGarden, because I have a little bit of knowledge, but not very deep. I looked at the website. So it's kind of a tool that is giving you a telemetry store. It's helping you understand how your level of instrumentation is, how well you are doing, and it's helping engineers to kind of get to a better place in terms of telemetry.
Exactly, yeah. So if you look at our website right now, I mean, I would ask you not to look at our website right now. Look at our website in a couple of weeks' time, because we prepared the website for what we are launching in 2 weeks' time.
Nice.
So I mentioned we have Rose this Wednesday, so in 2 days, and then the week after we are launching the free plan for OllyGarden, and that's what we have on the website right now already, but it's not completely ready. But what we have, so what is OllyGarden? We are providing tools or products to improve the efficiency of telemetry pipelines. And to me, the telemetry pipeline starts at the instrumentation. Because the pipeline that we are dealing with right now is so big, it's huge because of the amount of data that is flowing through the pipeline. The main problem that we are tackling right now at OllyGarden, it's the stage 0, as we call it, is by reducing the volume of the data so that we can make it more manageable. And we are doing that because we know that a lot of the data that is in the pipeline is bad telemetry. There's a lot of bad telemetry out there, is one thing that I heard, and I keep repeating. It's the title of the KubeCon talk that I have with Dan Blanco in a couple of weeks' time. I have a t-shirt with that, so I'm going to be wearing that there's a lot of bad telemetry out there t-shirt at the KubeCon talk. And so the first goal that we have is let's tell people what is bad about their telemetry. Let's get them to fix those issues first, and then we can tackle the other efficiency problems that we see throughout the pipeline. So we right now, OllyGarden Insights is our the main product that we have, and it is, in technical terms, it is one OTLP endpoint that you can send data to. You don't have to send 100%. You can send like 1% of your data to us, and you keep sending 100% of your data to your honeycombs, to your Datadogs, to your Grafanas, but then 1% to us. And we see the bad patterns. So, I've seen a password in the command line arguments for your Java application right there. So I know your JVM trust store password. So that's one insight that we can give you. And we can tell you, stop sending your trust store password to Datadog. And then in another data, we perhaps are seeing an access token coming back from an IGP server. And we can tell developers for the service payments, stop sending access tokens like your bearer tokens to Grafana. Like, it doesn't make any sense. And so that's the kind of insight that we are giving to people. We are opinionated about OpenTelemetry. We know OpenTelemetry from ins and outs. We don't care about other formats. It's not that we don't like them, it's that we are really specialists in OpenTelemetry. We help build OpenTelemetry from day one. So we know what to look for in terms of the problems. We know what is bad about OpenTelemetry, and we know what is good. So this is what we are doing right now. And with the product that we have, we tell observability engineers which services under their supervision are mostly affected by bad telemetry. So they go back to their software engineering teams, they share a link to the insight within OllyGarden, and they tell them, like, this is the problem that we saw. Like, just happened this morning. So somebody pinged me and said, one engineer in our team saw that they forgot to set the service name for a specific service. So they're just fixing that right now. So that's the kind of insight that we can give to observability engineers. So those are the people we care the most. And they give this information further. They spread this information. We don't charge per seat, so people can just click the link and invite people to the organization without focusing on cost or anything like that. Like, we really want people to just fix the instrumentation problems that they are finding. Right?
Yeah, that's very interesting. First question is, with this OllyGarden Insights product, how do you close the loop? So if you found those telemetry problems, how do you notify like which people?
So we have, right now, we have only enterprise users. So what I'm doing right now is things that don't scale. So what I do is once every couple of weeks, I sit down here for 1 or 2 hours and I look at their telemetry and I curate that manually. And I go back, I prepare a report and I show them, this is what I found about your data. Like one of the things that I found today was people were sending what were supposed to be in resource attributes. They were sending as part of span attributes, and that's kind of a mismatch that can be very costly because you repeat the same data for every single span instead of adding to the resource spans. Which anyway, so and that's manual process, but then we convert those into insights, and then we implement the insights and we place as part of the OllyGarden Insights. Right now, it's so people get notified by 2 ways. One is they get this report every couple of weeks that I manually create, or if they have time, they go to OllyGarden.app, like our application, and people can see the insights there in close to real time. So whenever we find a problem, we create a new insight in the database and we show that in our UI. The UI is beautiful, I like it, but it's one other UI that people have to look at. And this is a problem for me. One thing we experimented in the past was weekly reports. So people would get the reports per email. It wasn't where I see my bar at, right? So we decided to roll that out and do the manual creation of the reports. But eventually, we're going to get there.
Yeah, I actually like the answer that you are hand curating that. That's it's really meaningful. And just like a high level question before we dive deeper, where is kind of observability garden with regards to like the size or the maturity? I think you are pretty early. Do you already have an investor? The site looks great, by the way. So I think you have a couple of customers. You have investor money. Is that true?
Yeah. Yes, we do. We were very lucky to attract attention of investors at the very beginning. December last year, like Christmas last year was very interesting. So I got calls from different people. We were talking to investors like the day before Christmas Day. But we closed the round in February, beginning of February, with a VC that is already investing in a company in the observability area and OpenTelemetry. So they get open source, they get OpenTelemetry, they get observability.
Is that called a Series A or like a first round or pre-seed or something?
No, that's a pre-seed. That's a pre-seed, yeah. Nice. So that's really just for us to evaluate the idea and see where we can go. I think a lot of the theories that we had were right. And I think we are executing pretty much on the path that we imagined back then. One thing that I wasn't seeing as clear as I'm seeing right now is AI. I knew AI was going to be a big thing, and we would even joke with investors by saying, or for the past half an hour you haven't even heard the word AI, and they were it's
a good thing.
The business makes sense without the AI word, so let me pay attention. But I think right now is where all right, so I have to go back 2 steps then. Since the beginning of the year, I'm trying to force myself to use AI tools as much as I can. Not because I love AI, but because I see this is kind of the future of work. Like people in the future are going to use those tools. And if I don't know how to use them, I cannot serve them well in the future. Yep. And if I can be very proficient in cloud coding, then I know what are the bad things about cloud code. And one thing that was very, very clear to me throughout this year is that those tools, they are very useful. They can be used to really accelerate our development, but they are not always right. The code that they generate is not of higher quality than typical people. The instrumentation they generate is not better than humans. And if the instrumentation that we have today is bad, and it's not going to get better, but we're going to have more code, then we're going to have more bad telemetry in the future. So that's why we are so interested in this problem space, because it is only going to exacerbate from where we are. But one thing that we learned as well is what actually works, like what is buzzword and what is hype and what are the things that we actually use in our daily basis. And this proactive AI is where I see a lot of potential for the future. Like I mentioned Rose. Rose is one of the results of the whole experimentation that we are doing. Like if I can get Rose to generate a PR that I as an engineer, Juraci, I have high confidence about this code that this tool can generate, then that can really mean something to me. Not noise, not slop, like what, a lot of people are opening PRs, even within OpenTelemetry community. They're just getting like a bug report description, pasting into Cloud Code and expecting a good PR to come out, and it's just bad. This is not it. This is not what I'm talking about. I'm talking about the real PR with like focused, on a specific problem and providing value. And I think we can do that. And we could only come up with this scenario because we were using AI so much.
And for this Rose product, so what are kind of the ingredients and what is the big difficulty? Because what I kind of get is, have the pull request, you send a diff, you send it to AI, and then you have a prompt that you give it, and then there's actually, with relatively little effort, a lot of value you can generate there in terms of code review. And I imagine, okay, you have a bunch of OTel manuals that you put into the context and giving some stuff, and then, okay, we'll get something. So, like, how good is the kind of first version? How much iterations were there until it became usable? Is there some secret sauce on top of that goes in that make this product useful and good?
That's a good question. So I think we are using an architecture that we are seeing elsewhere as well. So we just had a meetup last week here in Berlin related to AI, and we saw an architecture that is very similar to what we are doing. And CodeRabbit published a blog post with the same, like the kind of architecture that they have, and we are following something that is very similar. Basically, it's one agent that is a puppet master for smaller agents. And the problem with AI is, the good thing and the bad thing is that it can get creative. It is non-deterministic. So our job is to make the non-deterministic parts used in things that we don't know, and make AI deterministic for the parts that we know the answer. For instance, let's use AI to analyze one line of code and say, like, we can use AST techniques to filter like what are the places in a Go code that generates a new span. And if we can get very into that line of code, like this is my PR, and on that line of code, I am creating a new span. And let me use AI then to infer what's going to be the span name. And does it match the patterns of bad span name or good span names that we establish as humans? Like our knowledge is encoded as part of that small agent. So what we do is we have one small agent that is responsible for judging the names of spans. And then, but that context was provided by a bigger agent or a tool that is very deterministic, like the AST kind of tooling.
Nice.
So I get it, the line of code that generates a new span. Now judge the span name quality here. And then we have another one that is very similar to that one, saying, is it a high cardinality span name? Because for OpenTelemetry, you should not have a high cardinality span name. So perhaps it follows the rule of good names, which is it has to follow the verb object pattern, like get space / payments, or publish space the queue name. But if I publish to a queue name where I have the user ID as part of the queue name, that's a high cardinality span name, and that's bad. We should not have that. And those small agents, they're very focused on one problem, and they fix that one problem. So we're going to end up having like multiple tons of small agents, each one dealing with one special thing, and one puppet master at the top calling the individual agents as they need and making summaries and making decisions. Like, should I then open a new PR? Should I get a human involved? And so on and so forth.
Fascinating. And I imagine the Puppet Master is kind of one of the frontier models with some special kind of context and so on. But for the lower models, the kind of specialized agents, are you kind of doing maybe some some I don't know on-premise deployed DeepSeeks or what kind of like variety of models and deployments do you use for that?
That's a great question. This is part of the experiment right now. So we are launching Rose as a research preview. So we have one or two of those the small agents ready and architecture ready. And I think so. I have to confirm with Nico. So he's the one actually building the thing. But I think we're only using Google models right now, and I think even the cheapest one. So Google Flash, Gemini Flash 2.5, because when you have such a sharp focus on that thing. It doesn't have to be different, like the Pro model, or it doesn't have to be Sonnet or Opus for Anthropic. It can be Haiku, right? Because it is fast and it's cheap.
Yeah, it's interesting. I mean, with my work, I'm just like, okay, probably just aim for the highest and maybe kind of check if it's 4.5 or 4. But I'm like, the variety of tests, like models I test, is low, and once I like it, I roll with it for a couple of weeks. And but yeah, if you are scaling a business and you want to send a lot of stuff to this, the cost differential becomes very soon very important. Yeah. And I mean, Claude is just too expensive.
I don't know. I mean, perhaps it is. But I think one of the things that I'm not convinced yet is that we're going to make money with Rose. Like, I don't think we're going to make money with Rose. I think because I still see instrumentation as commodity. So if you take like podcasts that I've recorded a few years ago, I mentioned that instrumentation is commoditized. OpenTelemetry effectively commoditized instrumentation. I think Rose is one of the things there that is going to help, that can make sense as kind of a product, but I think it's not in the future, like on the long run. It's a feature, not a product. It is. That's why we are also seeing like Rose is a research preview right now. So we're going to invite some people to try it out and tell us, is it here better than that one? And then the model would be one of the things to compare, to come up with the good solution. And then eventually we're going to see whether people are willing to pay money for Rose alone. It's going to be like an SKU. I feel like I'm an enterprise now. But it's going to be like its own product, but it's also going to be part of the enterprise offering for insights, because we see Rose playing very well with the insights that we generate. Right? So if we see an insight for the service payments, we can feed that insight into Rose and say, we found this problem on that service. And then Rose goes to that specific code repository, finds where is the problem, and sends a PR to fix that specific problem. So that's how we see the full thing going on. So you ask the full cycle. I don't think the full cycle, like the end-to-end, is going to be weekly reports or people logging into OllyGarden. I don't think that's the case. I think proactive AI is helpful there. Like, I found the problem. I'm not going to tell you what the problem is. I'm going to send you the solution already. I mean, that's how we tell people to act on as humans, right? So don't come with problems, come with solutions. The same with AI.
That's beautiful. And I'm starting to get more of the picture. It's like less a data layer or a kind of quality measuring tool. It's more like a like helper in the background that is like reading out the bad stuff, kind of watering the plants at some points, kind of nudging things in the right direction, right?
Exactly. So one of the things that we keep seeing, and this is one of the theories that we had in the past, and it is proving to be true, that observability engineers, they are so busy. They have so many fires to put off. Their hair is constantly on fire, and they are always, they don't have time. They don't have time at all. So and they are not enough. Like the knowledge is so niche. They're so focused on one thing that it's hard to get people up to speed. And because of that, in an organization with thousands of software engineers, they have like 40 observability engineers. And that's not enough. And what we want to do, but the knowledge about what is good instrumentation, what is good observability is in their minds, is in their heads. Like they know what it is. They just don't have the time to execute. and they don't have time to make enablement sessions every week for all of the new developers that are joining the team. So OllyGarden is offloading that kind of work from them. Like we can tell their software engineers what is good, what is bad. We show them what the high value things. They can just copy a link and send it over if they judge that as reasonable. And then people come to OllyGarden or to the pull requests, and the software engineers responsible for that service, they fix it. Now, the challenge that we have right now is how do we convince the software engineers that this thing here is worth fixing? Should they invest their time fixing? So on our OllyGarden Insights page, one thing that we are going to have in the next couple of weeks, or perhaps a little bit more, is in our Insight details page, we're going to have why they should fix it. Because this is one thing that is missing. By fixing this issue here, you're going to save X amount of traffic, so not necessarily money, and then there's going to be like a YouTube video with me perhaps telling people why high-cardinality is such a big problem, especially if you have a Prometheus database, and drawing like time series on a whiteboard and showing people the cardinality explosion and so on. So the enablement session is big. One of the things that we kept hearing from people that it's a never-ending work, because people are joining and leaving the company all the time. So it's very hard for us to just a high cardinality issue that we told people how to fix today is going to happen tomorrow because new software engineers are joining the team, right? And that's the kind of the thing that we're going to catch. So we're going to catch the problems with rows before they get into production. But if they are in production, then we're going to find this problem before it becomes an expensive problem, and then convince the software engineers about fixing the problem. So it is a problem because here's the explosion in costs.
Yeah. So I think that the dynamics of the business dynamics are really interesting here, because I mean, I think observability engineers, I don't know a company that actually has that term, but I think a lot of companies have them effectively, people that know about observability. Yeah. But it's not a role that you staff for, and it's not a role that is actually proactively contributing to bottom line. So if you are, as a business executive, think like, where am I spending my money? Observability engineers actually never on the list, more or less kind of by design. It's like support engine, like the physical people that run the call centers are never on the list. And so if you have a cost-cutting exercise, they are always the first people that are kind of looked at, or it's low-value work that you kind of don't replenish. And then you're understaffed. So you're by design always running understaffed. You're trying to understaff this so much that it kind of becomes like it doesn't hurt you yet enough that you really care. And I think this is kind of the equilibrium where a lot of these reliability tools kind of end up. It's like it's not a priority until it very much is, and then you kick up and do a few projects so you get back to acceptable, and then we don't care for a while. It's very rarely a differentiator. So maybe there are some really sensitive, either security or performance sensitive things where the cliffs are pretty steep, so you need this margin of error, so you invest a lot to kind of stay safe. But for like specifically web stuff, I don't know, this big AWS outage, like 16 hours, like I don't know, who cares? I mean, today I'm not shopping on Amazon or what, and I shop tomorrow, right? I don't really care. So I think a lot of this is kind of, it's actually not that important. And also a lot of the telemetry stuff you talked about is probably actually not that important. It's like, okay, the service doesn't consume so much telemetry until it really becomes a problem. And then you need to know what exactly to fix. Because if this kind of MySQL database that runs the blog still shit, that's okay. It can be like shit all day long. So I think this is kind of naturally, it's naturally a situation. It's also not a great situation. It's also, I think, a situation where companies are rather investing in tooling than in FTEs that are doing that on staff. But maybe let's start from this direction. What is kind of your ideal customer? How do these conversations start that actually convert in you coming on site and becoming such a partner? Like, what is your experience there, and what is your kind of target picture, how you see this kind of partnership evolve, and you're getting into those companies?
It's funny that you mentioned that, because costs are typically not the one thing that people care about when we talk to them at first. And it's funny because most of the vendors in this space, their messaging is like cost, like let's cut costs and so on and so forth. Like,
Cannot win if you are starting with that.
and I think that of course, one of the outcomes of good telemetry is that you pay less money to your vendors. But then it's really not just about that. It's really about improving efficiency of the pipeline as a whole for us. And what it means is, so when talking, so Datadog is one of our investors, as well as Grafana and Dash Zero. So one of the ways that, when I started explaining the idea of OllyGarden to one of them, they said, "Oh yeah, I get it. This is." We are not happy when our customers are sending us only crap, because then they pay a lot more money than they should, and we want them to get a better return on investment. So there is an angle to that, of course there is. But the real angle is, if you have good data, it's less data that you have to juggle with during an outage at 2 a.m. in the morning. Like you don't have to filter those many debug logs in production anymore. You just focus on the things that really you care about. Not only that, but for some companies, there is not enough of a pipeline or like network pipe that can be used to send all of the telemetry from them. Like data centers, they have limited capacity, even though it's the cloud, it's limited. And if you have only this size of a pipe to flow all of your data, and half of it is telemetry, like it doesn't make sense. So let's make it more efficient, so that everything else can be more efficient. It's CPU, it's memory, it's everything. Like, and especially human. During an outage, it is really about finding the right answers at the right time. We were talking to a company in the incident side of things the other day, and they were saying the biggest problem that we have is people's instrumentation nowadays is at best mediocre. And when we try to analyze their telemetry because of a part of an incident, we cannot get straight answers. Like we cannot get good answers because the telemetry data is so bad that they have. So having better data is good for the whole ecosystem. Now, when we talk to, so ideal customer profiles like ICPs, we help people. First, they have a collector already running internally, and if they have a collector running internally, they have somebody who set that collector up, and that's our observability engineer. Perhaps it is an SRE, perhaps it is a platform engineer, but it's typically not a small startup. And it's a company that has different sources of data, and they're sending data elsewhere. Typically, at that stage, you already have some data that you have to fix. Like you do have a problem to solve. So that's one. And what we are seeing right now is bigger companies. They don't know anything about their telemetry, and they are really. That's where we go back to they don't talk about costs. What they do say is, I'm interested in the governance. So I see so much data coming from so many directions that I need to know where my data is coming from. I need to know whether all of the teams are using the right attributes that I told them to use. Like there is one company in Brazil, they said, I need all of my teams to use one specific attribute to denote the correlation ID. I don't use distributed tracing, I use correlation IDs. I need that to be present in all of the log entries that we see. And if any one service is not using that, they want to be alerted. That's governance. Similarly,
and just hooking in there, I think there's a lot of truth to this, and it's something where a lot of organizations, I think, have interest in that. Because it's like, okay, I don't want to necessarily run with shitty telemetry, but how do I even attack the problem? Like, tell every engineer to do better telemetry does go nowhere. And then okay, measure the telemetry quality and make a score, or measure how many outages you had with a certain service. Yeah, you can start, but how do you define a telemetry score? And then you cannot, I mean, that is a research problem on its own, and then it kind of takes too long and nobody does it. So actually having a partner who can come in and run this project with me, or a tool that I can just plug in and kind of get per application a rundown of kind of here are the things, and gives me a red, amber, green state. That is, if you are interacting with management, you always need red, amber, green states and tables. That is the way to do it. And so then you can run this governance project, and you're never sure what exactly the value is, but you will kind of feel better, and you will actually hedge sensible risk. There's so much low-hanging fruit. There's so much thing. It's just like, okay, you just have the service name, right? We know which, like, we are getting telemetry from that service, like +1. We know that it exists, right? And so, like, having this stuff really in place, there is a lot of value, and there's willingness from organizations to do it, and there is a little bit of a, like, it's addressable, of course, right? But if you can address it in a meaningful way with kind of a positive value and relatively low overhead, that's a big plus.
I think that's one of the reasons we started Instrumentation Score as an open source, an open spec, because we thought, like, it cannot be the opinions of one person or one company. It has to be the opinion of an industry. So that's why we have Datadog, Honeycomb, Darcy, Splunk, Grafana, New Relic as people helping with the Instrumentation Score project. And it is one number that is unambiguous and is portable. It's a number that I can compare the services within my company, and I can use the same numbers to compare with other companies out there. And I can move from vendor 1 to vendor B, and the numbers should be the same. Like, if they all implement the same spec, the same version of the spec and so on, like, and they see the same data, they should come to the same results. So the number is meaningful, it's portable, and I can use to compare services. And if we have that, then we have an interesting part of governance also being tackled, which is, I heard that from somebody that I was talking to at the beginning of the year. They said, I just came out from a budget meeting with the whole IT department. I'm responsible for the observability part. And then when I saw a report of observability costs showing 20% is coming from one specific service, and the remaining of I'm making up numbers here because I forgot the numbers from the beginning of the year. Yeah. But the idea was there was one service that is very noisy. A lot of money is going into that for observability. And the percentage of the IT budget for that service was like 30% of that was observability. And people were asking these observability experts, like, is 30% good or bad? And the answer was, it depends. And then you look at the other service that is only like 10% of its IT budget is observability. Then you say, well, 30% is worse than 10, right? And when you look into that, the 10% is a reference data kind of service. So no observability needs at all, like very low observability needs. It's not critical. Now the 30% one is the one that is calling APIs, calling other services, calling message queues and blah, blah, blah. So the needs, and that one is a critical service. That one is like part of the business, the core business of the company. So 30% is actually quite okay there. Perhaps not 30, perhaps 25 or 20. But it's definitely way more than the other ones. And when you have the instrumentation score, it helps you visualize that. Like, it is 30% because it is 30%. Like, the instrumentation quality for that one is actually very good. So it is at the best. And perhaps the 10%, it is also a good instrumentation score. So it's also good. It's neither are wrong, or perhaps both are wrong.
I mean, it's an investment at this point if you are getting value out of it, and it's a critical system. And I think what you really want to avoid is just a system with badly tuned logs, which is just costing thousands of euros because you're just like logging too much for no one to look. And there's like a lot of value I think you can save in a lot of companies if you're just doing baseline log volume monitoring and seeing what's going on there. Yeah.
The second most frequent log message that we saw from one user was message received successfully. So that one, like a static message that keeps repeating itself, like it can either just be dropped. I mean, it's a low value message. Like what kind of message did I receive successfully? Like any correlations for me to, I mean.
It's a debug log that should be
a debug
in
log.
production.
Yes. Yeah. And the other thing is that log can be a metric. Like if it is not providing me any further context, I can just increase a counter, and that's so cheap, so much cheaper and so more efficient than a full string of text with timestamps and so on.
Yeah. Like I have one question. What would you say actually is good instrumentation for you? So when you're in a green field, and let's also maybe just like open up the wish list box kind of a little bit more, of if we were just thinking about like a piece of software, how would that ideally be instrumented? And in the beginning, we talked a little bit about the different approaches, and I think we all kind of settled on instrumentation should be in the source code. You should physically write, kind of emit this counter here and send it off. And there are so many different models. There is the kind of, what was that called? Like this programming model also in Java with kind of annotations that were externally managed. So you could kind of have a configurations file, just basically say which methods should be instrumented. There were kind of probe points, static probe points in Solaris, and I think these days we still have them in Linux as well. But those are kind of low overhead things that basically just give you a hook into the runtime or the binary during execution. Then there is runtime level instrumentation, aspect-oriented programming. That was what I was looking for. So on the JVM, or we can do that on Python maybe as well. Then there is the OS level stuff with eBPF and so on. There's maybe also the kind of external polling thing. There is the, I'm pushing stuff. So if I'm kind of looking at that spectrum of possibilities I have to basically answer the question, what is my machine doing, right? What would kind of be your ideal state? Where would you think that the end game would be when it comes to observability?
I like magic. I like playing tricks with my kids. I like getting coins and pretend they're falling off the ears. I like magic, but I when I'm debugging a problem, I don't like magic. I like to look at my code and know what's going on in there. I woke up a little bit earlier today and I saw a post about Zig, the language. And there was one thing that I read on Zig's website or documentation somewhere. Basically, what you see here is what is being executed. Like there's no magic. There's no, there's nothing that is being called, no hidden functions being called. They use one example, like if A plus B, the plus is an operator that can be overloaded in C and Ruby and some other language that you mentioned. That cannot happen with the Zig. Plus is never a function. And there's no hidden functions on D and blah, blah, blah. And even Go, you have defers and panic catches and things. If you look at Zig, everything that you see there is what was executed in that order. I like that. I like the Zen of Python. I like the explicit is better than implicit. I like the instrumentation together with my code. I like that. I'm different, perhaps. Not everybody's like me. To me, good instrumentation is instrumentation that you, as a person running that software, you can understand the behavior of your software at runtime with that telemetry without excess. So you have just enough information for you to understand what your application is doing in production at runtime. So if it is at low level, a high level, with AOP, with I love AOP. I mean, one of my first instrumentation projects was with JBoss, EJBs in general. So I implemented a few interceptors for EJB, and I thought it was really cool to see what all my EJBs were doing. I like EJBs, judge me. But I was doing, I saw all of my EJBs were doing, and I thought that was really cool. without looking at my code. And then we implemented a @traced annotation for EJBs and Java JSR. I won't know the number, but for annotations.
Yeah.
And then that worked as well. I like that. So as long as I can reason about, I can understand instrumentation. As long as there's no magic, that's fine. One thing that I heard from a company just last week is they are not doing eBPF instrumentation on that case because that was magic to their engineers. They would see things there and they would not find the source. We were also talking about, we can for the logs, we can pass it through a specific process, and that process can do the forgetting the name for that. So it's structuring the logs. So the legacy logs would be non-structured logs, and we could pass through a process that structures the logs. They would say, I don't like that, because my software engineers, when they go to the logging backend, they are not going to see what their applications are generating. They build the logs in their applications, they see one thing, they go there to the backend, they see something else. There is magic. I don't like magic. Right? So to me, coming back, sorry if I just go on and on, but to me, good instrumentation is it is an instrumentation that provides a telemetry that I can understand the behavior of my application at runtime without excess.
Yeah,
that's pretty much it.
That's definitely a goal I would definitely subscribe to. It's there's a fundamental duality. Programming is tell the machine what to do, and observability is understand what the machine is doing. And if we can do that, and it's like as simple as possible, then it's a success. And I think a lot of the trade-off is here in the right kind of level of interfaces and abstractions. So I think these trace annotations are really a nice touch on a lot of this. And if you think about error handling, there's like functional code is so nice if you're not doing error handling. It's just like you write down the good path, and it's so, yes, you can get so much done with so little code, and then you are kind of sprinkled in if error equals true in every line, or you have all this kind of messy edge case handling, and then the code is 10 times as long, and it's like okay, now it's production ready. It's a mess, but it's an honest mess because this is what you're actually doing. There are no kind of abstractions which are nice enough, and with instrumentation, I think very very similarly, it's good if you can hide it and make it not noisy, but if it's hidden, then it's complicated, and if it's magic and changes under you, it's potentially extremely costly if you are going down that debugging route. So I think we are both in the or I hear you at least as being in the explicit instrumentation in code. I'm not sure where I stand. I'm actually not sure, but I definitely get the appeal of that. I like that as well.
I think there is certainly a maturity to be achieved in instrumenting nothing at all, because instrumentation is not business code, and that's just dirty on my code. Like my code becomes dirty because it has instrumentation. It's something that doesn't belong there. So I can see that. The other side is I have too much instrumentation, manual instrumentation on my code, and then that's definitely distracting. Right, so I should look at the code, and I should understand what is the business behind it. But I would say that at least what I try to do for OllyGarden Zone code is instrumentation is there, it's visible, but it's not intrusive. Like when I'm doing error handling, I am getting the span from the context and adding the results of the operation to the span. So I mark the span as error, I add a message, and that's it. Nothing more. Perhaps one extra line of code at the beginning of the function saying, get me the span from this context. So I don't create a new span every method that I create. I just get the span from the context, and then if I need, I add attributes, I add events, or I mark the span as an error. And the same kind of logic applies to logging. Like the basic good patterns that we have with logs that we learned over the decades, they apply to general instrumentation as well, tracing specifically. Like you should never log and return the error. Like, so you either bubble up the error and then you let the parent handle the messaging of this error, or handle the error in general, or you log it and you ignore the message because it's not going to be logged elsewhere. Right, so logging the message becomes a user experience thing, and not something that is done at every level. And the same applies to tracing. Like, you should not create a span for every single method call, but you should create one that represents your business operation. And then if you need a high granularity, then you go there. The other nuance there is the necessity of instrumentation is also very fluid. So perhaps for a new application, I need more instrumentation because I don't know how it behaves in production. So perhaps I'm using a new algorithm for something, or a new technique for doing another thing. I need more instrumentation there to understand the actual behavior in production. Now, after a couple of versions, perhaps I'm happy and I can remove instrumentation. And then eventually that application becomes having more trouble in production. Then I add more instrumentation because now I need more telemetry there. So the necessities of the application, they change over the maturity of that application.
That's interesting. I have been there actually. But it's more like a developer educational exercise for me. I was like I even wrote the application, but it was like, what the hell is it seeing? Like, you are out there, what are you doing? Like, how much volume are those functions calls getting? And actually, what we ended up doing a lot for that was admin dashboards, internal web endpoints, where we were rendering internal application state. So that was kind of, the libraries had that by default, that we always kind of had this kind of, it even had a telnet thingy that can telnet into that and ask questions, but I was using the web UI a lot more. So you could kind of expose a lot of stuff there. Back in the day where you just had maybe like 3-4 pets instances of the same app. But yeah, it's like this information need, like tell me what you are seeing, not only the problems, so I can better understand what I need to engineer for that environment. And then at some point, received message, that's not a log that you want to see and pay for in your logs. That's something else. Yeah, my high level take is also that I think a lot of the instrumentation should be actually a lot more dynamic. And back in the day, it was SSH to the box, fire up a debugger or TCP dump and just like get the information out of this or modify the script, right? This is the best case if it was a Perl script. And now it's like a Kubernetes environment that I may not be able to log into. And then I have a CI/CD pipeline. So if I can run CI/CD in 20 seconds and be live, no problem. I can just go through that a few times within a debugging session. But it takes half an hour to deploy. I'm not doing that. And so I think like the next step for a lot of this kind of systems will be kind of interactive feature flagging or some form of interactive granularization or interactive, just tell me what this function is doing across a fleet, right? So that stuff would be great if that becomes available soon, or maybe, I don't know.
There is some great research being done at a university in the US on that topic, on dynamic in enabling and disabling trace points within an application. I don't know how much of that is public, how much of that has been published already, but that's certainly the next level. Like the next level to me is understanding when an application is having trouble and increasing instrumentation, and then whenever application is stable enough again, then reduce the noise. Like this dynamic
software development lifecycle management stuff.
Yeah, either that or just watch the application. Perhaps the problem is not in the application; it is in the database. But we need more information now.
Juraci, am I pronouncing your name right?
Yes.
Juraci. Okay, let's do it like that. Thank you very much for this conversation. I think this was so good that we can potentially just release it like that.
Sure.
let me thank you for this. And I think I'm just going to hit stop now.
Thank you very much for the invitation. That was very fun and yeah, very nice.
Good to hear.